Hello everyone, I welcome you all to this lecture. In this lecture, I am going to discuss the master-slave JK flip-flop. In previous class, we have already talked about the race condition. So to handle the race condition, I have mentioned there are three ways in which we can deal with it. The very first case is we can set the half of t, and t is the time period. So if half of t is less than the propagation delay of the circuit, then we can say race condition will not occur. In second case, we can use the S triggering. In case of S triggering also, there will not be any kind of such race condition. And in third case, we can go for master slave. So let's discuss the master slave operation. In master slave, we have two JK flip flop. One will act at a time as a master, another will work as a slave. So in that way, we can cancel out the race condition situation. So let me draw that. So in master slave flip flop, we connect two JK flip flops in such a manner. We assume that this is final Q and Q bar. Here we are getting Q and this is Q bar state. Now this is state we will connect to this input. Here we should have a clock. So here it is a clock. Let's say this is a clock pulse. This is clock, right? And then another JK flip flop which we are connecting here. Here we will pass the clock. So there is another clock which we have here. Let's say there's another clock we will pass here. Okay. Now this and both this clock we will connect. Let's say we are connecting this clock with this clock with the help of a NOT bit. We just complement it and we are passing this to next flip flop. So this is negating and then we are passing here like this. Okay. And these outputs we are connecting to this Q bar. We connect with this and Q from here. Let's say I take another color. This is, let's say, Q, and Q will connect here with this line. So this circuit will act as master slave flip flop, and we will pass here. So let's say this is J, and this is K. I hope you already know about this circuit. This is K pin and that is J pin, JK. And this flip flop which is here, that will act as master, and the other flip flop will act as the slave flip flop. So here you will get a Q and Q bar here in between, intermediate, writing like Q, and this will represent the Q bar. So because this will act as a master, I may write it like QM. This is the final Q, right? This is QM bar. Now this circuit will reduce the effect of toggling how it will reduce the effect of toggling? Let's see it. In toggling, you look at here, when in JK, when both the inputs are 1 and clock is also 1, and if it is level triggered flip-flop, then it start changing the state from 0 to 1, 1 to 0, 0 to 1, 1 to 0 over the period of t by 2. So in case of JK flip-flop, if you connect another JK flip-flop, this situation will not occur because these clocks are connected. So at a time only one flip-flop will be active. So if you are passing here 1, so let's assume J is 1, here it is 1, clock is let's say 1, and this K is also 1. So in case all these three are 1, initially you assume that, so I'm just taking one clock, so we can take a clock. So the clock light, we can draw the clock like this. And this clock we can repeat multiple times. So we can repeat it. So let's repeat it. So let's say this is the clock. Now if this is the clock, so this is representing CLK. So when clock is low here, after this negation, this circuit will be high. And if clock is high here, after negation, this circuit will be low. So when the clock is 0, it will preserve the state. Okay. And when, so this is connected here, so you assume that this is connected, right? Like this. So this circuit is like this. Now if you draw the pulse of QM, or you can say Q, we can draw like this. So let me take the scenario. Let me draw these reference lines. Okay. So let's draw the QM. Initially, I assume that QM was 0. So let's say if QM is 0, once this clock will become high, the QM will toggle, right? So if initially it was 0, the clock is high, J and K already I am assuming both are high. So it will toggle and it will become 1. Now after it becoming 1, this circuit is 1, but this clock, when this clock is high, this is low. So whatever the Q was, it will remain. So initially if we assume Q was 0, let's say I'm assuming Q was 0 here, it will remain 0. So in this duration, the Q will remain 0 if it was initially 0, because the clock is high here. So when the clock is high, this clock will be low, right? So once it is high QM, this will be high in this duration. Now when this will become low, so when the clock will become low, this QM will be preserved and this circuit will active. Preserved. So if it was 0, when the clock is low, it will remain 0. Okay, because it is not updating once the clock is getting low. So this circuit is not updating. Now this circuit is active. And once this circuit is active, this Q, earlier I was considering this Q was 0. Now that Q will become high. So at that time the Q will become high. So here when the clock is low, the Q will toggle and it will become high, right? So clock is low, Q will become high, and then the clock is again becoming high. So this, once this is high, the circuit will preserve the state. So this high will be remained to the next, this particular duration. I hope you're getting. So once this clock is getting high, this Q1 will toggle. So earlier it was 1, now it will become 0. Once it will become 0, it will come to this point, and because the clock is keep on high, so it will maintain this. And after this, once the clock is becoming low, because the circuit will not be functional, so it will preserve the previous state, so it will remain 0 till now. But in this case, when this clock is low, so this circuit will active and it will toggle. So when it will toggle, this will be low, so it will go down, and this will remain low in this duration. When the clock is becoming high, in this duration also, because circuit will be inactive, it will remain 0. So in that manner, this pulse of QM, we can draw it like this. And similarly, we can draw the pulse of Q, which is going like this, and so on. Right? Similarly, this pulse also will keep on going low and high in that manner. So the very important thing here, you notice that in master slave flip-flop, which we are implementing with the help of JK flip-flop, there is no issue of toggling we are observing here. So this, I'm assuming this pulse for QM, this flip-flop is acting as master, and this clock is for final Q clock, that is this. So there is no toggling. I'm saying no toggling or no race condition. Toggling is there, but no race condition. No race. So there is no race. I hope you are able to understand the concept of master slave flip flop. With this, I am closing this lecture. Thank you everyone for coming.